Hello everybody and welcome back to the bench. Today we're going to do a little speaker project together, and I thought this might be an interesting one to do a video on. What we have here is two pairs of Minimus 7s, the realistic Radio Shack Minimus 7 speakers. Now this set over here is stock and it's in good condition. They're working, they're fully functional. And this set here was a set that the woofers went out on them and were replaced with aftermarket speakers at some point in time, and I've already taken this one apart. Now I have a total of 3 pairs of these speakers. So I have the ones that are up here on the bench, and they're the ones that are my bench test speakers, and they're the ones that you hear on a lot of the videos that we do when we test out amplifiers and things. And they sound really nice for what they are. For the cost, these little speakers were a pretty good bargain in their day. As you can tell, and I'll show you this one cabinet that's taken apart, the tweeter is actually a very good quality tweeter made by Peerless, to my understanding. And I believe that the woofers, the original woofers in these, were actually either made by Morel or Peerless also, or maybe Foster Electronics. Either way, they were good drivers. As you can see, this particular version, and they made a couple different revisions of these Minimus 7s at Radio Shack. The cabinets are made of die-cast aluminum. They had some foam or some fiber insulation in them for damping material, and they had a relatively simple crossover. So what you see here is the low frequency driver is just directly connected to the speaker terminals with no filter at all, no crossover. And the tweeter on this model consists of a capacitor and then a 0.4 Millihenry coil shunted across the tweeter. Okay, so I think that would make this one a 12 dB per octave crossover. Don't quote me on that. I'm not a pro at all that stuff. So anyways, the original first ones of these that came out, to my understanding, only had the capacitor and no coil. So this one's a little bit better. But kicking around out there on the internet, there are a couple of people out there that have come up with an aftermarket crossover. It's like an upgrade kit, and it's said to really improve the sound quality of these speakers a noticeable amount. Now, I want to take it a step further though. Not only do I want to experiment with some crossovers on this, but I also want to experiment with these, and I'll show you what we have here. And this is why two of the sets of speakers are sitting out here. I went online and I actually went to partsexpress.com, and they had 2 speakers that will pretty much drop in fit in place of those woofers. Now these tweeters are excellent, you don't want to change those, but the woofers are a little bit lacking in their capabilities. So I found this one, which you can see is a has a polymer cone, has a rubber surround, 1-inch voice coil, nice big hefty magnet, and it has some pretty good specs on it. It's an 8-ohm driver, as you can see. There's the model PC105-8, and it's made by Dayton Audio. And it's pretty much a drop-in replacement for the original. The other one's a little more of a radical departure from a normal speaker. This is actually a micro subwoofer. And as you can see, it has a very large excursion cone with this big surround. It has a neodymium or a neodymium magnet, however you want to pronounce it. And it is a model ND, let's see if we can get it in there, ND105-8. It's an 8-ohm speaker, and it's also made by Dayton Audio. And as you can see, it has a raised pole voice coil inside there. and it's designed for very high excursion. And actually I saw some online demonstrations of this speaker, and they were getting some really low frequencies on larger cabinet size. Now in these little enclosures, I don't think it's going to perform as well at low frequencies, but I purchased 2 of each of these, and the idea is we're going to build a crossover, design and build and test a crossover for them, and then each set of speakers is going to get the different driver in it. And then we're going to, at the end of the video, we're going to try to compare these 2 modified sets of speakers with the original stock Minimus 7s to see what kind of sound differences and what kind of performance we can get out of them. So if that sounds like an interesting video to you, stay with us, stay tuned here, and we're going to see what we can come up with. Okay, let me get my microphone situated here. So the first thing I'd like to do is introduce you to a new piece of test equipment that I purchased, and it's made also by Dayton Audio, and I got all of this stuff through Parts Express. And let me start by saying, number one, Parts Express and Dayton Audio have nothing to do with this video. I'm not endorsing them. They did not contact me. I ordered this online and paid for it. The reason that I'm talking about this is that I've seen this on other videos out there and on other reviews, and was very impressed in what it can do, and decided to kind of take the plunge and purchase one of these for myself. So that's really what this is all about. So it's not some big endorsement, or I paid for it. So anyways, this is a device that the main purpose of it is to be able to test speakers, but it also has other test capabilities than just testing a speaker. It's really good for testing crossovers and how they perform in combination with a speaker. It has a component tester. It can test resistors, capacitors, and inductors. I really haven't done a whole lot of the functions that this thing can do. I've only just kind of scratched the surface. But we are going to use this to test our new drivers and to test the performance of the crossovers and so forth. So this is called the DATS, and this is the version 2. And I think that stands for Digital Audio Test System or something like that. When you get it, it just comes with this little dongle with 2 clips at the end. It plugs into your USB port of your computer. It comes with a calibration resistor, which is a 0.1% accuracy 1K resistor. It comes with the software and the user's manual on a CD, and that's pretty much all you get. So, like I said, I've just used the basic functions on this so far and tested it out, and again, I'm really impressed with what it can do, and I think you will be too when you see what all we can do with this. So let's go over to the software here, and I'll give you a little example of how this thing works. I have the software booted up now that goes along with this tester. And hopefully I have the lights set so that I don't get any glare. That's really difficult on this high gloss screen. Now you may wonder why I have this on a laptop computer and not on the main computer that's on my desk, with the monitor in the back. And that's because I did have a little bit of problems getting the drivers to play nice with my big computer. And the main reason is that there are other USB devices on that computer that were interfering with it, I think. And yes, I could have crawled behind there and unplugged things and messed around with settings, but it was just easier to set this laptop up. And the nice thing is it's portable, so I can actually take this away from the bench and use it to test speakers, in other places. So kind of like the way it's set up. So anyways, here's what we have. When you first open the software, it comes up to this screen, And this screen is it's a display for the impedance analyzer. It's a display for, there's like an oscilloscope mode, which I have not used yet. Okay, but you can click on, you can see this just has the graticules and the 2 channels, and it simulates an oscilloscope, and I'm not sure how that all works. So again, I have to read a lot more on what don't let the small size of this thing fool you. It can do an awful lot. But we're going to use this impedance analyzer mode, and as you can see, you can make it display on a linear scale or on a logarithmic scale. And there's 2 functions that it's showing. It's showing frequency down here versus phase angle. For instance, with inductors and capacitors and so forth. And it also shows frequency versus impedance in ohms, or resistance in ohms, however you want to word it. So it'll make a little more sense when we run a test. Now, you can see along the left-hand side here, you can set up the parameters of the test. And what this thing has is a sweep generator. So it's going to start at this starting point and sweep up to the ending point that you select. And it has a maximum range of 5 Hertz to 20 kilohertz. That's the maximum range that the signal generator inside this small device will accurately work. So it comes defaulted, as you can see over here, to the maximum settings. And it also allows you to set the lower and upper impedance on the scale as well. So you can kind of set, and what I'm saying is you can set the scale of your screen to match the range that you're trying to measure in, so you can get a really accurate chart. And this will make more sense, like I said, when I do the test. Now, along the left-hand side, there's an advanced test where you can measure the free air parameters of a speaker. The thing that we're going to use the most right now is called the impedance sweep. And really all it does is it starts at 5 Hertz and it sweeps up to 20 kilohertz, and it measures the feedback from the speaker as a representation of impedance. It can calculate the actual impedance at each frequency. And the idea is, if you had a perfect speaker load, it would give you a flat impedance response all the way through the audible frequency spectrum. But what you're going to see is that that's not the case, especially when you don't use a crossover or anything like that. Speakers have preferred frequencies that they like to operate at. One of those frequencies we call the free air resonance frequency. And then that's even affected by when you put it in an enclosure, and if you have a port, there's all kinds of things. And this device actually will open up a whole new world of what's going on in your speakers when you connect them to your stereo, and why proper box design, proper crossover design, and so forth are so important, so that the speaker has a nice flat sound and doesn't have, high spots and low spots in the frequency spectrum. So let's move over and let's do a test, and I'll show you what I have set up. I've taken one of the stock speakers. So this is the one that has the original drivers in it and has never been opened, it has never been taken apart, and is a fully perfectly functioning Minimus 7. And I've just connected it to a wire, just a speaker wire, to these terminals using the device here. And it's connected straight to your speaker terminals. That's how it works. Now I'm going to go back over and focus on the screen, and I'll run the test, and I'll show you what this thing does. Now hopefully I have this thing focused and the lighting good. I hope you can see everything okay. It's kind of hard looking through this little viewfinder here on the camera. And I'm going to go over here, and I'm just simply going to hit the impedance sweep, and it's going to make a sweep, and you'll hear the sound, hopefully, in the speaker as it does this, and it'll sweep from 5 Hertz up to 20 kilohertz, and then it'll plot the actual impedance of the speaker throughout that entire range. So let's do it. And there you go. So what are we looking at right now? Well, what we're looking at is this blue line represents the impedance that your amplifier would see if you were putting a sine wave at these particular frequencies into the speaker. So as you can see, your amplifier does not see a flat load of 8 ohms. So it's kind of a misnomer when you look at the back of a speaker cabinet. Let's look at this one, for instance. If you read this, you can see that right here it says input 8 ohms, but yet if we look at our chart, and this is really cool, I can pick like at 20 Hertz. Let's look at 20 Hertz. Right around 20 Hertz, you can see that this actually presents a 6.957 ohm load to your amplifier. Now, up here, take a look at here. If I click right on that peak, that's about 120 Hertz, 119.1 Hertz. And as you can see, it's presenting a load of 35.97 ohms. That's a very, very high impedance at 120 Hertz. Now, any of you who are really into audio will totally understand right away what this is, but for those of you who don't, that represents the resonant frequency of that speaker. So the woofer is actually working in resonance at that spot. So you have a resonant point of 120 Hertz for this speaker. Now every speaker is going to have this to some degree. You can also see the red line is a representation of the phase angle of that signal, if it's in phase or out of phase, and if it's plus or minus phase, out of phase. And you can see right around that resonance point is right around where the phase really starts to go out. It stays relatively flat at 0 degrees throughout most of it, but any place you have a peak in your impedance, you also have an out of phase situation. So if we look here, there's another peak, and this is probably where the crossover's coming into play with the tweeter. And you can see at about 1.7 kilohertz, roughly, you're up to about 15 ohms, and you're at a negative 9 degrees phase angle. Now, once you get past that, you actually hit a low spot over here where you go below 8 ohms. So at high frequency, really not that high, at 6.8 kilohertz, that you really start to see the action of that crossover come into play. And then as you get back up to 20 kilohertz, the amplifier or the speaker is presenting almost a perfect 8 ohm load up at 18.56 kilohertz, and it actually will rise up above that beyond there. So as you can see, this is not a flat or a consistent impedance throughout the frequency spectrum. It does change with frequency. Now, if there was a better crossover in here, you'd still have a peak. And that's just what, when the speaker is at resonance, you're going to have a peak. That's normal. That's going to happen. But throughout the rest of the spectrum, you would see a lot more flat frequency curve or impedance response versus frequency. So what this whole thing is showing us is that the crossover in this speaker is not very good. It's not very efficient. It's not really doing its job. Really, the whole purpose of the crossover in this particular speaker is to prevent low frequencies from overloading the tweeter and damaging it. However, you have spots where the woofer and the tweeter, since the woofer, the low frequency driver, does not have a crossover to filter out the higher frequencies that the tweeter handles, you have an overlap where both of the speakers are functioning at the same time, and it's additive. So it messes you up with your impedance. So if both speakers had their appropriate crossover components placed on them, and those crossovers were set in such a way that they would allow the low frequency driver to hand off the upper frequency range to the high frequency driver and vice versa, this would be a lot flatter. Hope that makes sense. Okay, so again, right now what we're looking at is system impedance. So this is for the entire, the woofer, the tweeter, the cabinet that it's in, which that affects things too, as well as the crossover. This is the system, the performance of a stock Minimus 7 as it sits. Okay, so we're going to go ahead and try to save this file so that we can come back later and compare it. I now have one of the new drivers, and this is the PC105-8 by Dayton Audio, and I am going to connect directly to this speaker in free air. And I want to show you a couple of things that you may not have realized about speakers. Now, just to give you a rundown, this speaker is laying flat on the magnet on its back on the bench. I have it connected up in free air, and I have nothing around it, so it's just kind of open. And we're going to go back over to here, and we're going to do our little test. Sorry about all the shaky camera. We're going to do our little test once again with just the speaker. So let's do this now, and you'll hear it once again. And there you go. So in free air, you can see that this speaker has a resonance point at about 95 hertz or 94.88 hertz. And you can see that when it's at free air resonance, it's sitting, it's presenting about a 25 ohm load. And also, if you notice, the impedance phase shift is very small right there, but just before and just after you can actually see the phasing going out, but that's normal. That's how these speakers react. If you look down here, it's rising, the impedance is rising with frequency, but if you notice it, there's no more bumps. It's a lot flatter because you don't have another speaker coming into play, and you don't have any crossovers coming into play. So that's what you're seeing right now. Now here's what another thing I want to do. We're going to take that same speaker, and I'm just going to turn it on its side like this. Now I'm going to have to hold it like this, but I'm going to turn it 90 degrees on its side. And then we're going to do the same test, and I want to show you what the difference is. So take a close look at what you have here. Let's do our test again. And if you notice, it shifts just a little bit. And that's because the actual weighting of the speaker. Likewise, if I face it downwards towards the bench to where it's almost touching the bench, and I do the same test again, you can see what a big difference it makes. And what you're looking at here is the influence of the air pocket between the face of the speaker and the bench. It has really, really changed the properties of the speaker. And I guess what I'm showing you here is that the air around the speaker, or the enclosure around the speaker, affects the mechanical performance of that speaker. And because the mechanical performance of the speaker is affected, it's also affecting the electrical performance of the speaker. Does that make sense? So how you mount this speaker and what kind of cabinet you choose will have a dramatic effect on the performance of this speaker, both with respect to impedance and with its frequency response. That's what this is showing. So now let's take it to the next step. I have my one speaker cabinet that's opened up, and I'm going to take these two wires that were originally connected to the low frequency driver, and I'm just going to connect it as is to this speaker, and we're just going to see in free air how this speaker performs with the tweeter and with the crossover that's in there as it is. Then we're going to actually change some things with a different crossover. Now, believe it or not, all I have right now is I have this speaker connected directly to this cabinet with the tweeter through the crossover. So this, with the exception of the driver not being mounted in the cabinet, this would be simulating that I just am dropping in this replacement low frequency driver in place of the stock one. Now, there are going to be some changes once you mount this in the cabinet, because the air pressure inside that box is going to affect the resonant frequency of this speaker. So that's the only thing that'll change. But as far as the crossover is concerned, we can see the effect of the crossover. Now remember what the original stock Minimus 7 system looked like. Now we're going to go over and do the same test on this one and see what we get. And I have to get things set up here, so I'll be right back. So let's see how this works now. And here you go. So you can see right here, first of all, around 92 hertz, 93 hertz is our resonance point for the low frequency driver. And it's in free air still, it's not in the box. That would change if we put it in the box. It would move either up or down depending on the box volume. The 8 ohm point, okay, is right here, this line right here. So you can see, below 20 hertz, it drops down to about 7 hertz, or 7 ohms, I'm sorry, impedance. But as we get closer to resonance, it creeps up until it maxes out once again around 25 ohms. Then it drops back down pretty flat, about 7.5 ohms, which is good. This is good. And then right around 2 kilohertz, which is, I'm suspecting that's the crossover frequency where the crossover actually comes into action. You can see that the tweeter actually presents a lower impedance to your amplifier, around 6.7 or around 3.7 ohms at 6.7 kilohertz. Now, for an 8 ohm speaker, it's presenting closer to 4 ohms to your amplifier. So obviously that's going to affect your sound. It's also going to affect the load that your amplifier sees at that frequency. So in a perfect world, we would want that impedance to be nice and flat. And the reason that you're seeing this is, there's several reasons. Number one, it's the type of crossover they're using. Number two, it's the fact that there's no crossover on the low frequency driver at all. And this driver can actually reach up into that 6 or 7 or 8 kilohertz range. And because of that, the two speakers are kind of working in parallel. And because they're working in parallel, you're getting 2 8 ohm loads in parallel is going to equal a 4 ohm load. So you would expect that. So can we fix that? That's the big question. Let's see if we can change some things in our crossover network to make this a little bit more realistic or a little more flat and reasonable. Let's see if I can explain what I've done. So I've just mocked up, really it's a cobbled together mess. I mocked up another crossover design. So the first thing I've done is I've eliminated this original capacitor and coil for the tweeter, and I've substituted it with just a direct 3 microfarad nonpolar capacitor in series with the tweeter. So you just have the positive lead coming from your amplifier going through this capacitor and into the tweeter. The negative of the tweeter just connects to the negative of the amplifier. On the woofer, we've also added a crossover, as you can see, and in series with the woofer, I've put this 0.4 microhenry, you can see 0.4 microhenry inductor in series with the woofer, and in addition to that, I've snubbed a 3 microfarad nonpolar capacitor across the terminals of the woofer. So this is what we call, I believe, a second order crossover. And it should change that curve quite a bit. Now I've left the original curve up there so we can see it, and then when we do the new one, you'll see how it changes all of this. Now here's the original curve that we had with the crossover, the stock crossover that comes with the speaker. Now we're going to try our new crossover with our new woofer and see what it does. And as you can see, it really changes things quite a bit, doesn't it? We have a really dramatic change here at this peak right here. You can see at about 3.7 kilohertz, I'm clear down to 1.3 ohms. So it's almost like putting a short across your amplifier. So this is still not perfect. Okay, this is definitely not the way I would want to leave it. So how do we do this? Now we can change and play around with different coils and different capacitor values. But there's also another way that we can work on this, and we could address this, and that is with a circuit called a Zobel Network. And what a Zobel Network is going to do is a combination of a resistor and a capacitor that we can put across the tweeter that will take care of this notch right here. It'll fill it in and it'll make the load be consistent. So let's, I'll just hook it up and I'll show you what we're talking about. Alright, I'm now going to try something like this. And what we have is, on the tweeter, I still just have a 3 microfarad capacitor going to the positive. The negative is tied to the negative here. The woofer, we have our 0.4 microhenry or millihenry inductor in series with the speaker. We have our 3 microfarad across the speaker, and then we have our Zobel network, which is a 1 microfarad and 10 ohm resistor in series, and it's in parallel with this. So let's see what that does. I don't know. I'm experimenting. Still not working right. Alright, let's see what we did wrong. Maybe we have something reversed or something. Okay, rookie error. Here's what's wrong. Let me explain it. What I did wrong. This was completely an error on Tony's part. If you notice, this capacitor and this coil are in series, and one end of the cap goes to your positive lead, one goes it goes to the one lead of the coil, and then from the coil to the negative lead. And I was using this terminal as the positive lead, so essentially this was being shunted across the entire network, which was causing that problem. So what I've done is I just took the positive lead and I bypassed that altogether. So that's no longer in the circuit. We've removed the old crossover and the influence of it totally. So let's look and see what this does now. With our Zobel network, you can see the messy Zobel network here. Our capacitor, our coil, and our capacitor here for the tweeter. So just like our little schematic. So let's shoot this and see what we get. Wow. Now, as you can see, there's 6 ohms, 7 ohms, and 8 ohms. This is floating right between 7 and 8 ohms almost the whole way across. And the only place that we have a peak is at the resonance point of the low frequency speaker, which is normal. We're going to see that. The rest of this is relatively flat. Now, just to show you the influence of that Zobel network, if I take it off, so all I'm going to do is disconnect this. I'm going to take this part right here out of the circuit just by unclipping it. And we're going to do the test again. Watch what's going to happen up here. Well, that looks pretty good too. We still have a little bit of a higher peak there. But if we put our Zobel network back in, makes it a little bit flatter here. And we can experiment with different resistances and capacitance. I just chose, I guessed at it. And what we can do is we can modify that Zobel network until we get this as flat as we possibly can. And you won't have any kind of curves or humps. It'll just be relative. We just want it to stay within that 1 ohm range there of fluctuation. So we're going to experiment with a couple different values, and when I get the one that I like, I'll come back. And again, this is how, when you have this this DATS V2 system, it's this simple to really test the speaker under real-world conditions and get it exactly perfect how you want it. The other thing we want to look at is our phase angle. There's with, and here's without. And you can see not a big change there, a little bit flatter without. So there you go. So let's experiment a little more and see if I can get this a little bit flatter. This bump here is what we want to try to get rid of. We want to keep that kind of level if we can. Well, there's about as flat as I can get it. And I'm very pleased with that because it's not moving more than 1 ohm. Between the 8 ohm and the 9 ohm range at, all the way out to almost to 20 kilohertz before it starts to peak back up again. So I would have to say that's a pretty good flat response curve. What I ended up with was, let me write it down, and I tried different combinations of things, but here's what we got in the end. It ended up being a 20 ohm resistor, a 1 microfarad capacitor, shunting across a 3 microfarad capacitor, and we had the 0.4 millihenry coil, and then we just had a straight 3 microfarad capacitor here. And that seemed to take care of the problem. Now, I can also put another coil across here, but I don't think that's going to make a whole lot of difference. Actually, I think that might make it worse, but hey, we're experimenting. Let's try it. Let's see what we can do. Now all I've done is taken another one of these 0.4 millihenry coils and just shunted it right across the tweeter to make it a second order crossover. Let's see how this affects it. And as you can see, that made it way worse. It actually caused too much drop in frequency at the high frequency range, around 10 kilohertz. So if we take that back out of circuit and just go back to our original, just the capacitor by itself, and we click that again, we get a much nicer looking curve. So I think that's going to be the proper crossover for this particular setup. At least that's the one I like. And so that's what we're going to try. So now the next thing is, let's wire this all up as we've tested it. Let's mount the speaker in the cabinet and put everything together and see how it performs. So a whole lot of hot glue and heat shrink later, here is our crossover network. I made use of the existing coil because the one we were using was this one, which is a 0.4 millihenry. And as you can see, the one that's already in there is a 0.4 millihenry. So really all we needed was 3 capacitors, a 3 microfarad, 3 microfarad, and 1 microfarad, and a single little 20 ohm resistor. I just put a 22 in there. This is a flame-proof metal film resistor. This is not going to handle super high power, so we don't have to worry about this being a real big power resistor. And I think everything is going to be just fine. So let's get this fitted back in here and put this together and see what it sounds like. Our little speaker's put together now, and I think we're ready for a test. So let's, I have it hooked up. I have the tester set up. Let's see what we get. Hopefully it'll be similar to what we had. All right. Well, right off the bat we can see that the resonance point has gone up a little bit. Remember, it was in free air, it was somewhere down around in the 93 hertz range, and now resonant frequencies at about 141. For this small of a system, that's, I think, pretty good. I think that's a good place to be. And as you can see, we're very flat along here on the high end. So I'm pretty happy with the way this turned out. Now the next thing to do is let's get our other speaker, and I'm going to just do the same thing to that. I'm going to build up the same crossover network, mount the other speaker in, and then we'll have a pair. And then we can actually take this and connect it to an amplifier and see what it sounds like. Alright, so we have our first set completed here and put together, and I just kind of wiped it down. The cabinets are a little bit scratched on this pair, but all in all they're in pretty good shape now. I did do some listening to them, and I'm going to save that till the end, till we're done with our whole project, to compare all 3 pairs. But one thing I did notice is with the Zobel Network, to my ears, the sound was way too flat. Everything was very well balanced, and I would say probably for just, at least for classical listening, I think it would sound good. But to my ears, and again, my high frequency hearing isn't what it used to be. It just wasn't quite as open of a sound of what I wanted. So I removed the Zobel Network. So I left everything else the same. So if you look at the schematic, if you just remove this portion right here, I just have the 3 components. And believe it or not, it came out, sound-wise, came out perfect. If you recall, there still wasn't a really bad drop in the frequency curve, or the impedance curve, without the Zobel Network. It's just the Zobel Network kind of flattened it out a little more. And that's certainly what the sound was like as well. The bass was really tight, but it wasn't really deep, and the treble was really smooth, but it wasn't really high. So it was kind of, everything was kind of balanced and flat, which in some cases you may want that. But for my ears, I liked it without the network better. So that's the way this one turned out. And I did do a quick test, just comparing it to the original stock speakers, and it's a very noticeable difference in the sound. Lot tighter, nicer, better sounding bass, more power handling capability. The treble was pretty similar. It was very good. I mean, these tweeters sound really good in these speakers, right, as you buy them stock. So it got a little bit smoother, but it was still it's very good with the stock speakers, I think. So the next thing we're going to do now is might be a little more of a challenge than this first set, and that is we're going to go ahead and try to fit these subwoofers. Again, kind of a radical departure from the first thing that we did, so it should be interesting to see what we can get this thing to do. So all right, let's dig into the next set of speakers and see what we come up with. I have my next speaker here set up to the test jig, and we're going to go over here and see what kind of results it gets in free air. Okay. So as you can see right off the bat, the free air resonance of this thing is a lot more radical than the last speaker. When you're at resonance on this one, we're at 61 ohms, which, you know, from the 35 ohms or so that the other one was, you can see this speaker's a lot more unruly. And that's because of the high compliance cone and the loose surround on it. So you're going to see things like that. You can see it doesn't really start to flatten out till about 500 hertz, and then at 500 it just takes off to the moon again. So you can see this is really a radically different design of a driver than the last one. The last one I would call a full range driver. This one's actually kind of a strange agent because it's really technically a subwoofer, but it's so tiny that it's a mini subwoofer. But it has shares a lot of properties with the larger subwoofers. So you can see crossover and speaker volume and the how much stuffing we put into the box. All those things are going to have really radical effects on how this speaker will perform. So we're going to have to really, this one's not going to be as easy to mess with the crossover, because really I'm going to want to mount the speaker and kind of test it, then take the speaker back out, change something, put it back in. So it's going to be more tedious than our last project. But the idea is I want to see if I want this one to be more of a kind of a punchy bass kind of design for such a small package, just to see what we can get out of it. So let's get the other set apart and see what we can come up with. Now the first thing you're going to see is that the speaker doesn't perfectly line up with the old one. The mounting holes are actually, instead of being slotted, they're just round holes, and they just barely don't fit. So I may have to notch these holes out in order to get this speaker to mount down properly, but it does fit perfectly in there, as you can see. Now I have this just connected the way the other one was, and for comparison, here is the speaker that came out of it, and you can see these Minimus 7s were not junk. They were very good speakers. The cones are pretty loose on them. Yeah, they're pretty high compliance, but as you can tell, they have great big magnets, and there's your speaker. It's an 8 ohm. So they're, you know, paper cone, but they're certainly a very good speaker for what they are. So let's now connect back up to our test jig, get rid of the glare, and let's see what this thing will do just without any crossover, just connected the way that the original driver was connected in it. And you can see, just by putting the box in there and having the tweeter with its crossover in there, you can see what a big difference it makes. Now let me hold the speaker in a little bit tighter, because obviously it's not screwed in, and we'll do another sweep. And you can see it changes that peak a little bit, but the The tweeter and everything is not working the same. So just like the first one, we have that great big dip. So right around that 8K, 7 to 8 kilohertz range. And you can see right there, 7.26 kilohertz. So once again, we want to try to do something with the crossover to flatten that all out. And you can also see that we have another little hump here in the impedance. So this speaker is really going to need some sort of a crossover. So let's connect something up and see what kind of change we can make. Now, just to give you an idea of some of the differences from these Minimus 7 speakers, this is the fiberglass insulation that came in the speaker that we're working on right now. If you go back in the video and look at the fiberglass from the first one, it's more than double the amount. So you can see they've tinkered around with some of the settings, in this speaker through its different generations. The other thing, you can see they use a different brand of capacitor, although I think it's the same cap. This is only a 40 degree, 85, okay. And the coil looks a little bit different, but, because at least it has some tape wrapped around it. But you can see they did make some little changes over the years. So the next thing we're going to do now is I'm just going to remove the insulation, put the speaker back in, and just to see how much difference that makes. Okay, once again, I'm going to get this lined up. Let's go back over to our test here. I'm going to hold the speaker down like the last time. I'm going to come over here and let's try it again. Okay, so you can see the insulation didn't make a whole lot of a change. It shifted everything over a little bit, gave you a little higher frequency on the resonant frequency, but other than that, that really didn't make much difference. So now let's try to put something on the woofer. We're going to leave the tweeter crossover alone for right now, and we're just going to try something on the woofer. And once again, we're going to try a 0.4 millihenry. By the way, when you want to calculate the values of a crossover network, there are many online. Just go into a search engine like Google and type in speaker crossover calculator, and tons of them will pop up, and you basically type in the information about the speaker that you purchased and the frequency that you want to cross it over at and so forth, and it calculates the values of capacitors and coils. But what you're going to find out is no matter how accurate or how elaborate of a calculator you have, it's not, in the real world, it's not always perfect. You end up having to listen to it and kind of tweak the values of the components to your taste. And I really mean that when I say to your taste, because once again, we all have different hearing, and even beyond, if we have the same hearing, we all have different sounds that we like better than others. It's a matter of personal choice. So in my example of the last speakers we just did, even though it was a really flat, electronically flat signal and everything, and the response curve, I didn't like it as well. So we made a little modification by removing the Zobel Network, and it opened it up, and to me it sounded better. And again, we'll listen to all these when we're done. So let's start with a coil alone on the speaker and nothing else, and we'll try it again. Alright, we've just added our coil, our 0.4 millihenry coil, to the woofer, and let's see how that affected our chart here. You can see, to me, that even made it worse. So let's try the capacitor now on there as well, and then see if that makes any difference. I now fitted the capacitor, so now we have the coil and the capacitor on the woofer. We still haven't touched the tweeter. So let's see what this does now. Okay, so if you look, not very good still. The tweeter is going crazy at high frequency. And the woofer still has, we have one hump here, and then we have the resonance point here, and then it starts creeping back up around 1 kilohertz. So this speaker is way out of range. So we're going to have to figure out what to do with the crossover on this thing to try to solve the problem. And this is why I'm saying you can't just throw a speaker in a box and expect it to work, because these are the kinds of things that you have. And if you recall, when we put the stock speaker on there, it was not perfect. It still had the dip and everything, but it was a lot better than this. So this woofer is really not happy with this tweeter the way it is right now. So we're going to have to really get kind of do some radical things with the crossover to get everything to flatten out and work properly. So let me do that, and let me do a couple of little tests, and then we'll be back. So after a lot of work, here's what we have come up with, and this is about as flat as I can get this. And here's what we ended up doing, and believe me, I spent some time on this, but here's kind of what we came up with for the values. For the tweeter, we're just using a 3.3 microfarad capacitor again. And for the woofer, I really needed to have this combination or everything completely went out of whack. So we have a 0.4 millihenry coil. We have the 10 microfarad capacitor across there, and then the Zobel Network really needs to be in there. It makes a big difference, with a 10 ohm and a 10 microfarad. And there's the results. So I actually was able to connect the signal generator to it, and you can see here's a signal generator mode, and run it through its through the different frequencies to test it, and it actually seems to be responding really well. So I think that's a winner. That's what we're going to pick for our values and for our crossover. We're going to put this all together, and then we're going to test it out and see how it sounds. Here's a shot of our first crossover network that I made up, and I'm on my way to making the second one here for the second speaker. But as you can see, here's the two 10 microfarad capacitors over here, and then there's your 10 ohm resistor, the little 3.3 microfarad for the tweeter, and over here is the coil for the woofer and the output for that. So you can see that's kind of got it all neatly put together, put some hot glue on it, and I think everything's ready to go. So I'll get this speaker put together, and then I'll get started on the next one. Here's the finished product here, and the one thing I just wanted to note before I put the grill on here for everybody is, if you notice the corners here, these fit in the holes perfectly, but the screw holes in the frame are just slightly smaller than the original driver. So what you have to do is, in order to mount these properly, you're going to have to nip the corners open, kind of like to make a little notch. So all you're doing is you're taking the speaker and you're just kind of opening this slot the whole way out to notch it. And then I also, just for good measure, put these little washers underneath here just to give it a little extra rigidity. It's fitting in there perfectly. It's tight. Everything's good. And I ran a test on it in the cabinet, and as you can see, it turned out really, really well. Sorry about the glare. So yeah, I'm pretty excited about this one. So let me get the other speaker put together, and then we'll set them up and see if we can do a little test. Well, now that everything's all done, let's put these things to the test. Now I'll tell you how I'm going to set this all up. I'm setting my microphone record level and everything. Again, we're going to use the blue mic. I really enjoy how that thing works. And I'm not going to change the volume level or any of the settings on the amplifier at all. I'm using a Pioneer SA9100, and I have it, I'm going to set it one way, and regardless of what the volume difference is or anything, and I'm not going to change the record level, nor am I going to normalize the audio level. So if it's quieter or louder or anything, hopefully it'll pick a little bit of that up. Now the compression, on your on your software, and the compression on YouTube is going to adjust that a little bit. Probably we can't escape that, but we'll try to do our best. And then I'm going to do a song clip. The song that I'm using is from the YouTube library, and I'll try to list it in the bottom of the video. And the main thing is the one that I chose is pretty top heavy with the mid-range and so forth, because all in all, this is a small, tiny little speaker system. They're not going to deliver big, heavy bass no matter what you do. It's all about moving air and having enough box volume for the driver, and these are small drivers, so I don't expect heavy bass out of any of the three, but we'll just see what happens. Maybe there will be a big difference. One of them will be the clear winner, and maybe they won't be. I don't know. But I'll leave that up to all of you to tell me in the comments what you think. I'll just put them three out there. I'm going to do about a 2-minute clip of each speaker, and hopefully we'll be able to see if we made any improvements with our two different designs. Well, now that the tests are all done, I'll give you my opinion for what it's worth. This one pulled away by a good margin, in my opinion. And the reason I say that is I don't know if the microphone or the software or anything's going to pick up the differences. I really won't know till I upload this and kind of go onto YouTube and kind of listen to it the way that you will be listening to it. But in real life, this speaker was clearly a winner to me. And that kind of surprised me, because I kind of thought this woofer design here was going to be, for the small cabinet and everything, was going to sound a little bit muddy and flat and not have any kind of response, you know, other than kind of boom and sizzle or whatever. I couldn't have been more wrong. This was one of the most balanced, smooth sounding speakers of the three. And I have to admit, I'm really impressed at the improvement it made. You know, this wasn't a very expensive driver. I'll try to put a link down there for you. Forgive me if I forget to do things like that, everybody. I have a lot going on at work and everything, and I don't always get everything done that I want to do in these videos. So that's why I kind of try to do the follow-ups and Q&As once a month for the things I miss. So don't be afraid to ask questions. I won't be offended. But anyways, yeah, this one sounded the best to me. They're going to end up being my new test speakers on my bench. They're physically a lot lighter than the other two. The stock speaker and the the polycone driver, full range polycone driver, both had huge magnets on them, ceramic magnets, which added a lot of weight and a lot of bulk to the inside of the cabinet. This has the small, tiny little, if you recall, neodymium magnet, and I think that made a difference because it possibly reduced the, or increased the box volume, the air volume inside the box a little bit, maybe. I'm just guessing at this, everybody. But whatever it is, I really like the sound of this for what it is, and there it is. You see what I did. You see the crossover that I used. If you have any questions, feel free to contact me on this. If you want to do this project for yourself, it's actually a relatively simple project to do, and I think any of you can do it. So there you go. Again, I thank you for coming along with me on this video. I have another exciting one coming up here in the near future. And until then, I wish you all the best of health, best of happiness and joy and peace in your lives. I hope this video finds you all well. And until next time, have a great day, and we'll see you next video. Bye-bye.